it's given that the two, let me just little zoom it. Yeah, it's perfectly fine, I think. So in this figure, okay, there are four ropes: rope 1, rope 2, rope 3, and rope 4. And this is the fifth rope, where which is used to suspend the weight W. Okay. In the figure, if the tension in the rope, if tension in rope 1 is 12 kgf, okay, tension in rope 1 is given to you as 12 kgf, right? I think it's fine. That is, if this is rope 1 and the tension in this rope is 12 kgf, then what is the weight of the object that we need to find? So the main key in solving this question is to understand that what are the components of forces acting in the x direction, and summation of that should be 0, and similarly the forces acting into the y direction, and summation of that will be 0. So in this figure, the forces which are acting in equilibrium, okay, at these junctions, let's say these are the two junctions A and P, two junctions, okay. So we'll just calculate the forces over here and try to solve it, okay. So let's say for the point A, so we can say at junction A, what are the forces acting, we need to calculate at junction A, that means this point, right? So at junction A, we can see the just draw the free body diagram like that. What are the component of forces? Okay, if this is point A, right, then you can see here the in the rope 2 there will be a tension. So just mark it with T2, right, because this is connected with rope 2, right? So this will give you a tension of T2. Similarly here in the rope 1, so the component of force acting leftward, this will be T1, right? Now this is 3, so T3 will be there. So the component of force acting towards x direction will be like this, and this is equal to T3 cos 53 degree, right? You know the component, if this is T3, here is T3 cos 53, and here it's T3 sin 53. So we will be using both of these, okay, in evaluating. So this at junction A, these are the forces for rope 1 T1, rope 2 T2. In the right hand side, T3 cos 53, which is acting due to this rope, third rope, right? Now the component which is acting downward, the y component of the same T3, that is equal to T3 sin 53. So I think all these are only four forces acting at junction A. Just check it. Okay. So what we will do, the component of forces acting in x direction should be equal to 0, and the components of forces acting in y direction should be equal to 0. Okay. So just we'll solve it. So in the x direction, you can see T1 is equal to T3 cos 53, right? So we can write T1 is equal to T3 cos 53. because this is acting left, this is acting right. So into the x component, all this will be equal to 0. So T1, and from 53 37, the component 3 4 5. Okay, so we can put up the value of cos 53 as 0.6. Cos 53 is equal to 0.6 and sin 53 equal to 0.8, right? Just use these values. Okay, so it can be written as T3 into cos 53 is 0.6, right? So this is one of the equation which is available with you now, right? Now going to the y component, this one. So when you compare the y component, what you will see, T2 which is acting upward here, this is equal to T3 sin 53. So T2 is equal to T3 sin 53, and in the next step we can say T2 which is acting upward equal to T3 sin 53, and T sin 53 is 0.8, right? So this is equal to T3 into 0.8, right? So this is another equation which we are having now. Okay, so these two relations were derived now. Now what we will do, as we draw the free body diagram at junction A, what are the component of forces? Similarly, we will do the forces acting at point B, right? So we will write at junction B, at junction B, as we calculated for A, this was A, this is B. So at junction B, what are the forces acting? You can see. So just draw it. If this is B, you can see the component of forces from here is T4, right? So draw it. T4 right hand side, right? This one, this is the fifth rope. Okay, so this will give you a tension of T5 downward, right? And here the component of 3 cos 53, T3 cos 53, right? Here, so it will give you T3 cos 53, because this is the rope 3 and A and B are connected through a rope 3. So the component of T3 in this direction, horizontal direction, will be T3 cos 53 when you are at junction B, as we have calculated here T3 cos 53, T3 sin 53. So here also is T3 cos 53, and in the upward direction is T3 sin 53, right? So we'll write the same. So here it will be T3 sin 53. So there are 4 forces acting at point B. So similarly, summation fx summation fy equal to 0. The forces acting into x and acting into y should be equal to 0. So we will be solving it now. Since summation fx, that means all the forces acting in horizontally and the forces acting vertically should be equal to 0, right? When you equate the horizontal forces, you get T4 is equal to T3 cos 53, right? And when you put up the value, you got T4 equal to T3, and cos 53 is 0.6 into 0.6. So this is another relation which we derive, right? Now when you summation of Fy0, that means forces acting in the vertical direction upward should be equal to the vertical direction downward. So this shows this, right? So that means summation Fy is equal to 0. If you consider in the same direction, all these forces will be acting as a 0. So from here we can say T5 acting downward, right? The T5 which is acting downward should be equal to T3 sine 53. T3 sine 53. So this will give you T5 as equal to T3, and sine 53 value is 0.8 into 0.8, as we have taken over here, you can see, right? So this is the fourth relation which is derived. Now we have four equations, 1 2 3 4, right? Now what we will do, in place of T5, we'll just solve it. So value of T1, T3, T2, T4 and T5, okay, these are the all the component of forces or tensions which are acting into these different ropes, right? You can see into these different ropes, and through the free body diagram at the junction, the components of forces at junction A and B we have evaluated and come up with these four equations, right? Now just solve these four equations, right? So from here T1, that means it's given that if tension in rope 1 is 12 kgf, that means this value of T1 is given to you as 12 kgf, right? So we can write from equation 1, since T1 equal to 12 kgf is given into the question, right? Then this T1 equal to T3 into 0.6, T3 into 0.6. So this will give you the value of T3, that is 12 by 0.6, 12 by 0.6 equal to T3, which will give you the value of T3, that is 6, the decimal will be replaced 120 by 6 equal to 20 kgf. So this is the value of T3. This is the value of T3 which is calculated, right? Now the value of T3 is known to you, then what we can do, putting the value into the second equation, that is T2 equal to T3 into 0.8. Since T2 equal to T3 into 0.8, from here you can see, so we can write T2 equal to 20 into 0.8. Why? Because T3 is calculated as 20, right? So this will give you 16 kgf. So this force of the tension in rope 2 is calculated, right? So this is calculated as 16 T2, T3 is calculated as what, 20, and T1 is known, so T3 is 20, T1 is known to you, that is 12. So all this T1, T2, T3, all these values are calculated, right? Now what is the value of T4? from the above equation T4 equal to T3 into 0.6. So the value of T4 can be calculated. T4 is equal to T3 into 0.6. T3 into 0.6. That means 20 into 0.6. That is equal to 12. So T4 is also calculated as 12 kgf. Now value of T5. T5 is calculated as T3 into 0.8 using this equation, you can see, right? So this is equal to the, just put up the value of T3 as 20 into 0.8. This will give you 16. So the value of T5 is also calculated, which is equal to 16 kgf. T4 is 12 kgf, T1 is 12 kgf as given, T3 is calculated at 20 kgf. So T1, T2, T3, T4, T5, all these values are known to us now. All these values are calculated, you can see, right? Now when you consider the weight, this was the weight, so from here the weight, for the weight, if this is the weight and rope is suspended through rope 5, this weight is suspended through rope 5, then T5 will be the tension into this rope and this will be the weight W acting downward, right? So from here we can say W is equal to T5. So we can write W equal to T5, right? And the value of T5 we have already calculated. What's that? The value of T5 is 16 kgf, right? So, and we have calculated the value of T1 is given to you, but we have calculated T2, T3, T4, T5 all. So from here you can see W equal to T5 because this weight is suspended through this rope, right? And the value of T5 is 16. So we can say that 16 kgf is the weight. 16 kgf is the weight. So the weight of the body as given is 16 kgf, and this is our answer, right? 16 kgf is this suspended weight which is calculated. So in this way, just draw the free body diagram and just see the forces acting at those junctions. So here we have two junctions, we consider those points. So at any point you can consider and see how many forces are acting at that point and just solve it. You will get your answer. Thank you so much for watching.